Okay, let's try that. Try that. There we go. Okay, so I'm going to start this lecture on population growth with kind of a puzzle for you. It's one of those kind of word games that will make us think a little bit. And so here's the scenario. If we know that world population has been growing at a rapid pace for the last 200 years. And I'm going to show you a graph of that rapid growth in just a couple of minutes. And it's really amazing. World population has been growing extremely rapidly. Today, we're over 7 billion people on the planet. Now, here's the hypothetical. Go back, 30,000 years ago, there was one person for every 200 square miles of the Earth's surface. So there really wasn't a lot of people populating the planet 30,000 years ago. In fact, I could have written actually 10,000 years ago or 5,000 years ago. Maybe I'll change this. So imagine, for example, the whole region of Southern California, Los Angeles, Orange County, San Diego, that whole area, there's one person. That's what it would be like. That's what it was like going back a few thousand years. There was only one person for that much ground. Now here comes the mind twister, in that in just 1,000 years from now, in the big scheme of things, 1,000 years is not a long time, there will be 100 people for each square yard of the Earth's surface. Now, a yard is 3 feet long. Picture a football field. A football field is 100 yards. 1 yard is just really, 1 square yard is like 3 feet by 3 feet. So there'll be 100 people for every square yard. Now, of course, that's physically not possible. There's really only room for maybe 2 people at most squeezing into a square yard. But if you do the math calculation, that's the number that you come up with. And so what this little puzzle does, I hope, is try to kind of force us to grasp how rapidly population growth can take place. Now, when you watch the video this week about Paul Ehrlich and the population bomb, and you listen to Paul Ehrlich's pessimism and doomsday scenarios about population growth rapidly outgrowing or outpacing the world's food supply and so on and so forth, this is why he's so concerned. This kind of number. So let's go now to look at a graph of this rapid population growth that I've been talking about for the last 200 years. And this here is a pretty ambitious graph. It shows population growth throughout human history. Now, it's kind of a very rough estimate here. If you go back, looking at the graph here on your left, right near the X and Y intercepts there, go back to 160,000 years. That's kind of when the records show that humans first appeared on the Earth's surface. Something like 160,000 years ago. I can't even comprehend that, but that's what the textbooks say, those people who study that kind of thing. And the graph takes us all the way up to today, 2020, and in fact, beyond. It goes to 2150, and that's kind of an estimate. So what we're looking at here is, for most of human history, there hasn't been a lot of people living on the Earth. For most of human history, there was, a couple 100 million people at best. Um, Now, one of the key dates here go back to the year 2000. No, I'm sorry. Go to the year 1800. The year 1800. That was 200 years ago. And you can see the year 1800 there, the little red bubble kind of on the right now, on the bottom. So that was really a milestone in human history, in the Earth's history, because the world population for the first time hit 1 billion people. So it's pretty mind-boggling. It took over 100,000 years for world population to hit 1 billion. But then we look after that, how rapidly population growth took off. And it went from 1 billion in 1800, and it shows here 1945, it had increased to 2.3 billion. It more than doubled. And again, by the year 2005, world population hit 6.4 billion. Today, actually don't know the exact number off the top of my head. It's somewhere over 7 billion and is projected to hit 9.1 billion by the year 2050, just 30 years from now. So from one perspective, I think the perspective of people like Paul Ehrlich, this is a very scary scenario. And what does this mean for the future of humanity? It also very much has a strong bearing on cities and the capacity, the capability of cities to sustain large populations, because the majority of this population growth that we see here in the last 200 years has taken place in cities. We have, since 1800, become an urbanized world. Prior to 1800, people lived in small communities, agrarian kinds of communities and societies, farming communities, heavy agriculture, very small towns. Now we're an urbanized world. And so Los Angeles is kind of, in a way, the future. Large urban areas, a lot of cement, to put it that way. So this gives us a lot to think about here. Now, demographers, that's the name of people who spend their careers studying population growth and population change and shifts and so on, often use the term doubling time to refer to how rapidly population growth can take place. Or in other words, they refer to doubling times as a means of helping us grasp how rapidly population growth can take place. And we can see here from 1800 to 1930, world population doubled from 1 billion to 2 billion. So it took 130 years for world population to double. Then to go from 2 billion to 4 billion, it took another 45 years, from 1930 to 1975. Now to go from 4 billion to almost 8 billion, which is where we are today, it took something like another 45 years. So anyway, this gives us a sense of how rapid population growth can take place. The year 1960 was kind of a milestone because world population hit 3 billion. And this was the cover of Time magazine in 1960. So it was a really big deal to hit 3 billion. At that point, people thought, world population couldn't possibly expand much beyond that because of the problems, especially food shortages that much of the world faced. Now, this idea here forms an important backdrop to Paul Ehrlich's book, The Population Bomb, which came out in the 1960s. And this is about the time that he became very concerned about population growth. It shows the world population, and it shows world population growth by the second. It's literally a clock that shows you how many more people are being added to the world by the second, by the minute, by the hour. It also has the same information for different fun, interesting kind of website to look at. So now we can ask, okay, well, what determines population growth? And why does it grow so rapidly? The first part of this answer is pretty straightforward. It's kind of basic, bare bones. If you sit down and think about it, you think, okay, that makes sense. There are two things, the birth rate and the death rate. Those are the two main factors that determine population growth. The more people that are being born, the more people will inhabit the earth. The more rapidly people die, fewer people will have on the earth. So these two things, and we know then that this kind of makes sense. Okay, we can say, okay, we have world history, we look at this population growth, but what explains the spike? What explains the rapid population growth? And that part of the equation is a little more complicated, but I think pretty straightforward when we think about it. And this is the notion of exponential growth. Now, exponential growth can be explained in a couple of different ways. The word exponential growth is used in different contexts. So, for example, with the coronavirus, one reason why health officials are so concerned about the coronavirus is that it spreads rapidly and it can grow exponentially. So, for example, let's say that you had an arena open for a hockey game or a basketball game, and somebody brings the coronavirus with them, and 200 people are infected. So, when those people go home, each of those 200 people infects 3 or 4 people in their community, especially maybe in their house. And those people in turn will infect several people. So the pie starts to grow more and more rapidly if you don't put a stop to it. What would be another example? Exponential growth is similar to compound interest that you receive when you put money in a savings account in a bank. So for example, if you put $100 in a savings account and you get 10% interest, after the first year, you'll get $10 in interest, so you'll have a total of $110. Now the second year, you're going to get 10% interest again, but this time 10% interest on $110. So you will have more than $10 of interest after that year, but 10% on $110. So you have $11. So each year, that amount of interest that you get grows. And this again is this idea of exponential growth. And that's why it's a good idea to put money in the bank and save. Another way to explain it, if you take a rock and you throw it into a lake, the first kind of wave of pools that surround the rock as it creates this push of like these rings of water that get pushed out. they kind of get bigger and bigger. It expands more and more. Another way to explain it, let's think, just common sense, sit down, think about it. It's not, that easy. But think about it. Think of 100 people having children versus 1 million people having children. The population where you start with 1 million is going to grow much more rapidly because 1 million people are having kids. So I hope that kind of makes sense. And that is why this population growth can be so rapid. That's why you can come up with a statistic that says, okay, 1,000 years from now, there's going to be 100 people for every square yard of the Earth's surface. And this is why, again, Paul Ehrlich and modern day doomsayers, I should add, are so concerned about population growth. I should have said this earlier. There are people, a lot more people like Paul Ehrlich, who continue today to voice the concerns that he has had. And he actually is still alive today. He's, I think he's retired. He must be retired by now. But he still is making and expressing the kinds of concerns that he's been making since the 1960s. And so here he is. This is Paul Ehrlich. This is him in the 1960s. And, real brilliant guy, as you will see from the video if you haven't watched it yet. He was a professor at Stanford University, and his area of interest and expertise was in studying insects and the ecosystems that they live in. So one of the interesting things about ecosystems where insects live and other animal species is that you can witness this kind of rapid population growth over the short period of time. So whether it be mosquitoes or flies or whatever can exhibit rapid population growth. And that's what he was looking at. And he would see that some kind of insect would grow beyond the capacity for that particular ecosystem in which it lived could support them and sustain them. And this is the concept of carrying capacity that you'll hear in the video as well as the readings. Carrying capacity. So that was his concern. And he thought, if I'm studying butterflies in a particular ecosystem, an ecosystem being in a certain mountainous area, a certain place, particular creek, particular place where that particular insect, in this case butterflies, thrives, that these butterflies can rapidly produce, and soon there's too many of them. There's not enough water and food for them to live and survive, and they start to die off. And he said that is exactly what's going to happen to the human population. Here's a quote from his book, and again, as I mentioned in the introductory lecture to this class, sometimes we in urban studies and planning, as well as other, social science disciplines, sociology and so on, you study some things that are a little bit frightening in a way, but and a little bit, pessimistic. But I guess what it's all about, and it's all about going from this kind of pessimism to trying to solve the world's problems. But anyway, from his book, he said, the world, especially the developing world, is rapidly running out of food. In fact, the battle to feed humanity is already lost in the sense that we will not be able to prevent large-scale famines in the next decade or so. Now, he said this in 1968. We are now in the year 2020. There have been some instances where there have been some famines, especially in poorer countries. But humanity is still here. And in 1968, we were just a above 3 billion, and today we're at 7 billion. So this is kind of a real puzzle. I mean, Paul Ehrlich's statement here and his arguments he makes are very compelling, but we still have a puzzle here. We're still here and we're still growing. And yeah, some people in the world have at times, you know, didn't have food, but we're still here. So what's the deal with that? Now, Paul Ehrlich and his colleague, they came up with this equation called the IPAT equation. It's kind of interesting. And I should note here, he made a little bit of a shift here with this equation. Early on, he focused solely on food shortages, saying that population would grow so rapidly, there wouldn't be enough food to sustain a large population. Now that turns out to be, if you look at it just that way, it turns out to be that that's not true. And I don't think he's ever really admitted that that's not true. But human history shows that it's not true, because through technological innovations, we have been able to produce much, much more than we ever imagined in agriculture. We've been able to produce much more food to feed the world than we would ever could have imagined several decades ago. We can produce more food today than the world can eat. So the ability of technology and agriculture to increase food output has been tremendous. Now, whether he saw that or not, it's not entirely clear to me from what I know about him. He kind of shifted gears a little bit to say, okay, well, not only will we run into problems with a lack of food, but we're also, as a result of rapid population growth, going to destroy the environment, and that's going to kill us. So it's kind of some kind of mix there between, some kind of combination, I should say, between environmental problems and a lack of food. But I say that because in this equation here, we have I on the left-hand side. Left-hand side is, you're looking at the PowerPoint, and that equals environmental impact. Then on the right-hand side, you had population, the number of people, times A, affluence, and that's referring to the kinds of level of and kinds of consumption patterns that humans engage in. And on the very far right is technology or pollution. So this is it's kind of straightforward, but a little bit vague, so not completely straightforward. So what it's saying here is that the more people you have, the more they're going to consume. And the more they consume, the more they are going to destroy the environment. That's the P times A times T. So P, again, population, and you have, let's think of the United States, people consuming a lot of goods. And to consume those goods, that requires a lot of energy, and it ends up creating, for example, a lot of carbon emissions. Carbon emissions are now eroding the ozone layer and contributing to global warming. Some argue that global warming is going to undermine the planet and really be a problem. So the population would be the number of people. Again, the A would be all the stuff they're consuming. And the T is kind of the pollution side of it. Carbon emissions, toxic chemicals, plastics that are now in our ocean, and which are infecting fish. The list, we can go on for a long time here at the ways in which our consumption is polluting the environment. And all of this, P times A times T, has an environmental impact again. And so this is Paul Ehrlich's IPAT equation. Now, I think there's some problems with it. We don't have to agree with it, but I think it's helpful it's good to know it. It's compelling. It forces us to think about some of these issues. And it's on just a everyday level, this is kind of something good to know that you'll be reading the LA Times, for example, 10 years from now, and an article will refer to Paul Ehrlich and the iPad equation, and you'll go, ah, yeah, I know what that is. Now we have this guy here, Julian Simon. And if you haven't watched the video yet, I would suggest that you pause this lecture and go watch the video now, because Julian Simon is a big part of that video. And Julian Simon takes the complete opposite approach of Paul Ehrlich, the complete extreme opposite. Julian Simon is an economist, and his views reflect the ideas of most economists. If you take an economics class at Cal State Northridge, for example, I can guarantee pretty much that your economist professor will agree with Julian Simon. Economists have a kind of unique perspective of how the world works, especially how the economy works. And I think these ideas, while I don't completely agree with them myself, I think, or whether we agree with them, you agree with them, it's pretty compelling. So he says here, and there's a quote at the bottom, resources are not limited in any practical or definable way. So what does he mean by that? I think if we focus again on agriculture, and as kind of as I mentioned earlier, Paul Ehrlich was wrong on this account. If we focus on agriculture, we could say that, okay, yeah, Julian Simon is correct. Because from Julian Simon's perspective, the world can produce food, will find ways to produce food. And through innovations, new technologies, new ways of doing things, we will discover, if we need to, ways to produce food. And we've done that. I say we, if you look at the world economy, nations that produce agriculture can produce more food than the world needs now. So from his perspective, food resources are not limited, as Paul Ehrlich maintains. Now, Julian Simon extends this logic to all resources, that there are no limits to the resources. And importantly, I think what he's saying is that there are resources out there that we don't know about, that we don't consider resources right now. And one example, this comes out somewhere in the video, if you go back something like 200 years ago, oil was not a resource. People knew about oil, and it was kind of an annoyance to those people who lived in agricultural areas, or really any areas where there was kind of oil bubbling to the surface. It got in the way, it was sticky, it was messy, there was no use for it. I don't even know if there's really a name for it. Now, fast forward to the early 1900s, oil becomes a major resource now. Something that was useless and worthless 200 years ago is now invaluable and has transformed the world. So you can apply that thinking to other kinds of resources also. So it's an interesting debate. I personally tend to side with Julian Simon, but not completely. I think that he underestimates the damage that can be caused to the environment. Economists like to assume that environmental problems will kind of solve themselves in a free market economy. And that, I think, is a pretty limited kind of way of thinking. But you can decide for yourselves. And we'll see. So now I wanted to mention this concept again, and I'm almost done here with my lecture, the concept of carrying capacity, because it's an important one. And I used the concept earlier in the context of butterflies. if a butterfly population in a particular place, a particular ecosystem, begins to multiply, it may outgrow the food supply. And that refers to carrying capacity. Carrying capacity is the resources needed, required by a particular population to sustain itself or to survive. So we can think of carrying capacity for the humans. And that carrying capacity has grown qualitatively, as they say, dramatically in the last, few hundred years. So again, in agriculture, we can produce more food than we need because of technological change and innovations. We could sit here and come up with a list. We'd have to do a little research. We couldn't come up with it off the top of our head, but we could do a little research and we could come up with hundreds of innovations over the last 100 years that have enabled agriculture to increase its productivity. We could think of innovations in other areas of life too. I can't see you, but if I could and I asked you who is a major innovator that you can think of, some would say Steve Jobs, although he passed away. He's still prescient in our minds with the iPhone and that kind of thing. That has kind of transformed our lives in many ways. Anyway, going back here to this person here, Norman Borlaug, I think that's how you say his name. He's referred to as the father of the Green Revolution. He won a Nobel Peace Prize in 1970 because he discovered a way to breed wheat that was disease resistant and that would grow in difficult environments. This was crucial, especially for places like India, where food shortages were severe, and a lot of their staple crop was wheat. So this is one example of many that transformed agricultural productivity. Now, I think this is my second to last PowerPoint here, and I wanted to throw this in. Let's shift gears a little bit now and go back to world population growth. This is an interesting graph because you can see most of the world's population growth in the last 7 or 8 decades has taken place in less developed countries. A less developed country is a country that tends to be poorer, doesn't have as many resources, doesn't have an advanced economy, tends to have lower levels of education and that kind of thing. Some of the countries in Africa would be good examples of less developed countries. The majority of population growth is taking place in less developed countries. In the more developed countries like the United States and Germany and countries like that, population growth has slowed down. You can see the population growth for the more wealthier countries in the gray part of this graph. The population growth, as you can see, since 1950 has been pretty slow. And in fact, some countries, I think like Germany, there's a couple of others, they're really struggling with zero population growth or negative population growth. So that on one level, I think is some positive news that perhaps there is a way that we can slow population growth and have some control over it. We're not butterflies. We're not insects. We don't live in ecosystems in the same way that butterflies do. And I think this is something that I'm sure Paul Ehrlich could acknowledge, but I think he underestimated this. Humans, we have the capacity to control and transform nature. Butterflies can't. Butterflies cannot invent a tractor so they can grow more food for themselves. They don't have brains. humans do. And so there's that. And so this idea is really an interesting one, that the more developed countries have really slowed their population growths. Okay, so I'm going to leave you with this question here. What can we do to slow population growth? What have countries like Germany done to slow population growth? Did it just occur naturally? Did they take certain actions to do that? Why is population growth so much more rapid in the poorer countries? Does a country have to become wealthier for the population to slow down? So these are just a handful of questions that people are spending their lives studying and trying to answer. We're not going to be able to answer them here. I think if we were in a class, we could have a discussion about some ideas. But the point I'm trying to make here is that there are no agreed upon complete answers to these questions, and they're very important ones that we need to think about. Okay, so I think I'm going to end that here. And this is I'll have, as I mentioned, just one lecture each week. And we will talk to you guys later.